Okay, so this is Miss Backfish, and I am going over the triangle congruence quiz we did in gifted geometry on Wednesday. And this first question I have already gone over with one of my classes, or so I think it was an individual asked me about it. But it also is probably one that if you missed it, you can probably tell what happened going back. So when you're going through this, it says, given that triangle GTN is congruent to triangle KQM, it's all about letter order. So I think the person that asked me about it turned out they just missed the not. So be careful about that. If you got A, it may be that you missed that it was supposed to be not, and you just chose the first one that worked. Because TNG, that's the second letter, third letter, first letter. Second, third, first would be QMK. And so that works. And so you just go through like that, like NG, that's last letter, first letter. So that goes with MK, last letter, first letter. So that works. This is the first one where the order's not right. So MKQ, that would be last letter, first, second. So that would be NGT, and that's not what this says. So that's why number 1 was D, is because that's the only one that's not in the right order. Okay, number 2, it says given QMT is congruent to KPC. First thing I would do on this one probably is draw it. Now, you don't have to worry about the triangles looking the way they're supposed to do because you don't know what they're supposed to look like yet. I just draw 2 triangles that roughly almost like equilateral sized. Just know that you're not looking at it and saying, oh, okay, these look equilateral because you're the one who chose to draw it that way. You're just using them to see which sides go with which sides and that kind of thing. So I would label them the same way in terms of like I did left, top, right for QMT, and so now I'm going to do the same thing for KPC because it helps when it looks the same. This says angle QMT is 74 degrees. That's this angle up here. So 74 degrees. Angle MTQ, that's this angle right here, is 52 degrees. Okay, now, one thing I could stop and do right now, you could do this later too, is because I have the triangle congruent statement, I know what goes with what. So angle M is the second letter, goes with angle P. So this also has to be 74. Angle T is the third letter here, so that goes with angle C, so this also has to be 52. So here it says angle KPC is 2 times x plus 7. KPC is this angle right here. So this is 2 times x plus 7. So in other words, I can say 2 times x plus 7 equals 74. And I would probably, instead of distributing, I'd probably divide out the 2 first. So x plus 7 equals 37, and x equals 30. And then we can look at, it says PCK is 3y plus 16. PCK is this angle right here. So this is 3y plus 16. So 3y plus 16 has to equal 52. Subtract 16 from both sides. And I've got, what, 36? And then I divide those sides by 3, and y is 12. Okay, and that's what I was asked for, is to find the values of x and y, and I just did. So well, x is 30 and y is 12. All right, next up, choose the letter combinations below which refer to valid reasons, theorems or postulates, for claiming that 2 triangles are congruent. Choose all that apply. This is my list. I keep showing you guys this list or something like it. That's the list. That's what this list is. These are my triangle congruence postulates or theorems. Kind of basically, they're my triangle congruence reasons. So AAA does not work. AAS, yep. ASA, yep. SAS, yep. ASS and SSA are the same thing. And they both don't work. This is the same thing as that. HA is not one. SSS, yes. And then CPCTC is probably the most common wrong answer on this one. CPCTC does not say that triangles are congruent. It says that parts are congruent. So it is not a reason for saying that triangles are congruent. It's a reason for after we already know the triangles are congruent, we can pick any pair of corresponding parts and say, well, these angles will be congruent, or these sides would be congruent. And last but not least is HL. So there are 5 of them. And there they are. Okay. Number 4, give the abbreviation for the triangle congruence postulate or theorem, which can be used to prove that the triangles shown are congruent. If they cannot be shown congruent, type NEI for not enough information. We were given one pair of angles, and then we were given a pair of sides. So we have an S and we have an A. The only other thing we know without being told is that we have a pair of vertical angles. So that's another pair of A's, or that's another A. So now I just have to figure out which of these applies. Those are not right triangles, so HL is off the list. So it's just 4 possibilities. 2 A's and an S is either this or this, depending on whether the S is in between the 2 A's. Remember, we talked about what it meant to be the included side. If you go here and you look at the vertex of one of the angles and the vertex of the other angle, and you connect them, that's the included side. That's not the side that's marked. Same thing over here. Vertex of my 2 angles, that's the included side. Not the one that's marked. So it is not the included side, which means we will not put the S in between the 2 A's. So it's AAS. And if you write SAA, that's the same thing. Okay, number 5. Give the abbreviation for the triangle congruence postulate or theorem, which can be used to prove the triangles congruent. Okay, blah, 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 blah. We get that. All right, so this one we have a pair of angles. Then we have a shared side. This side is in both triangles, so I can mark that as congruent. And then there's nothing else. Okay, I don't have any information that would tell me these angles are congruent. I don't have any information that would tell me these angles are congruent. It's glitching. I hope it's not glitching in the recording. Sorry. I don't know anything about those sides. I don't know anything about these sides. I know nothing else. So that's not enough information. Okay. Any questions about that page before we go on? Nope. Okay. Y'all feel free to jump in if you have any questions. Number 6, give the abbreviation for the triangle congruence, blah, blah, blah. Got it. Okay. So I have a pair of sides. I have a pair of angles. Then I also have a side that's in both triangles. That's the same segment. So that counts. So I have 2 S's and an A. There's not any right triangles, so it's not that. This is 2 A's, 1 S, 2 A's, 1 S. Here's 2 S's and an A. Be careful about the fact that if it's 2 S's and 1 A, it could be this, or it could be ASS, which doesn't work. So you have to make sure it has to be the angle in the middle. So we've got side, and they meet at the angle, so that's true. And on this triangle, here's a side, they do meet at the angle. So yes, it is side, angle, side. Number 7 and 8 are what additional information type problems. What additional information must be given in order to prove that triangle MNP is congruent to triangle PQM by side, angle, side? Okay, so let's look at what we have right now. I know the side in the middle is congruent to itself. So I got that. The next thing I know is because I have parallel sides here, those are going to give me some alternate interior angles because they make like a Z shape, like that. It's like a zigzag. And when that happens, the alternate interior angles are the ones that are like the inside corners of the Z. Excuse me. Okay, now, these sides are not parallel. Okay, so you cannot say, and I had some people wanting to do this, you can't say that these angles are congruent. because that would only be true if this is z, which means this would have to be parallel to this. We don't know that. We don't have that information. So we can't say that about those angles. All right. So what additional information do we need for this to be side angle side? Well, here's a pair of sides. There's the angle, so it must be the side on the other side here. Like, in other words, this side and this side meet at that angle. Over here, it's this side and the one we already know meet at this angle. The arrows don't make it congruent. The arrows just mean they're parallel. So we need to know that those sides that have the arrows on them are congruent. That's what I need. I don't know it. I'm just marking what I need there. So I need to know that PQ is congruent to NM, which is right here. Because now, if I know that, I've got a side angle side. Number 8, what additional information must be given in order to prove that XYZ, triangle XYZ, is congruent to triangle FEG by angle, angle, side? Okay, here's an angle. We've got one pair of angles. If it's AAS, then I'm going to have another pair of angles and a pair of sides, which is what all these are, so that's cool. Okay, so AAS. It might not be a bad idea. I don't know. A little time consuming. But if you have time, it might be something you want to come back to later. It might not be a bad idea to draw it a few times. Like X, if you have trouble on these especially, this type of problem. This is what I've got. And I deliberately drew it sloppy so that you know you don't have to draw it real neatly. The first one says Z is congruent to, well, we already know X. Let's do those. We already know this one and this one. Okay. First one says Z is congruent to G. And XZ is congruent to FG. XZ is congruent to FG. That would be angle, side, angle. So it's not that one because the side is between the two angles. Okay? However, if I moved the side, it could be, well, I can't really move it there, so let's just go on. And you could try each one of these. X and F are congruent, and then let's see, Y and E, that's this one and this one. And then YZ is down here, and EG is over here. That looks good to me. That's two pairs of angles and the side that's not between them. Okay, I would go ahead and check the other ones just to make sure, but that is your answer. If you got this one wrong, what I suggest doing is exactly what I just did here. Go back and draw the triangles and mark the things that was on, like if you chose D, mark this and mark this and mark what's already given. And you'll probably see why it's not angle, angle, side. Like maybe the side is between the two angles. Okay, number 9, it was sort of a getting at a big picture situation problem. Okay. The reason I chose this problem was because what I wanted you to see is it looks like these triangles are almost proven congruent. We're pretty close. We have two pairs of sides and then we have a shared side. So I could probably prove that those triangles are congruent by side, side, side. But you're not being asked to prove they're congruent, the triangles. You're not being asked to prove the triangles are congruent. So if I'm not trying to prove triangles are congruent, then I'm not going to use this, ASA, AAS, any of those. Those are my triangle congruence proof reasons. So all of those would be if the last thing I needed to say was that two triangles were congruent. That's not what I'm saying. Okay, well, this could possibly work if we had vertical angles, but we don't. Those aren't vertical angles. So that rules out B. Transitive property would only be something I would use if it was like, I already knew that angle A was congruent to angle B, and angle B was congruent to angle C, and then angle A is congruent. There's no other angles mentioned here. We didn't talk about any angles in the proof. Definition of angle bisector, we didn't talk about any angle bisectors. The big picture we were getting at here is that CPCTC proves that pieces of congruent triangles are congruent. So if you're trying to prove parts, either a segment is congruent to a segment or an angle is congruent to an angle, and you think that you could prove the whole triangles are congruent, then that's probably where you're going. You're going to prove the whole triangles are congruent, and then the very last step say, okay, now I know that these parts are congruent. by CPCTC. Okay, so that's G. Next up, we got some proofs. Complete the proof below. Given GH is parallel to IJ, and that's already marked with those little arrows. Also that angle H and angle J are congruent, also marked, and given that GH is congruent to IJ. So that's this little mark right here. Okay, that's what we're given. I'm supposed to prove that the triangles are congruent. Well, there has to be something that's not given or marked, which we can go ahead and mention all the given stuff. Here's one's mentioned, here's one. This one is mentioned, but not, no reason given, so we need to say that's given. Okay, and then HGI is congruent to JIK. So HGI, that's right here. JIK, that's right here. How do I know those are congruent? Well, what I have here, remember parallel, anytime you have parallel, you need to think about parallels and transversals. This is what I've got going on here. Two parallel lines, and it's being crossed by a transversal. GK is the transversal. So those are corresponding angles. So that's how I know those two angles are congruent, because they're corresponding angles for those parallel lines. So I would say corresponding angles postulate. If you said theorem, like I said, I did not take away from that. Corresponding angles postulate. And then I have what you see here marked. That given is already there. And so now I'm just ready to say that the triangles are congruent. And every time I say in a proof triangles are congruent, the reason has to be one of these. In this case, because there's no right angle, it has to be one of the first four. So I look at what I've mentioned. I mentioned a pair of angles, another pair of angles, a pair of sides. So I'm leaning heavily toward two A's and one S. Angles, angles, sides. So that's one of these two. So I basically just have to decide if the side that's marked is the side between my angles or not. Here's an angle vertex, here's an angle vertex, there's the included side. Yes, it is the one that's marked there. Let's make sure in the other triangle also. Two vertices, and then there's the included side. Yep. So it's angle, side, angle. Next up, number 11. Complete the proof below. Given C is the midpoint of BD and AE. Okay. Angle A is congruent to angle E. Okay, let's go ahead and mark that. That was given. AB is congruent to ED. That's this. AB is congruent to ED is down here. So the first thing I have to mention is, how do I know that AC is congruent to EC? That's these two pieces. And how do I know that BC is congruent to DC, these two pieces? That comes directly from this. And it also helps you think about it because it's the previous step. Remember, if we're going to use the word midpoint, then we're also going to talk about what it means to be a midpoint. If you're going to tell me that C is the midpoint of AE, then I'm going to say, oh, okay, these two sides are congruent. These two segments are congruent, which is this right here. If you're going to tell me that C is the midpoint of BD, here's BD. If C is the midpoint, then these two segments are congruent, and that's them right there. So this is definition of midpoint. Next, we have angle ACB is congruent to angle ECD. ACB, ECD. Those are the vertical angles. And this is one of those cases where we have so much marked that's really getting cluttered. Okay, so here's the deal on this one. Those are vertical angles. I got to fill that in. Vertical angle theorem. Angle theorem. We have so much marked that it could be lots of things. We don't have any right triangles, so it's not going to be HL. But I do have two angles with the side between them. Two angles with the side between them. So it could be this. I also have two angles and the side that's not between them. Two angles and a side that's not between them. That works. I have side, angle, side for both of them. Side, angle, side. And I have side, side, side. I have all three sides for both of them. So it could be any of these four. Any of those work. So any of those is a possible answer. All right, last but not least, complete the proof below. Given AC bisects BCD. AC is this. If it bisects this angle, that means it cuts it into two congruent pieces. That's what this next statement says. Angle BCA is congruent to angle DCA. That's because of the definition of angle bisector. Or you could even just say definition of bisector. You can't say definition of segment bisector because we're bisecting an angle and we're talking about how it makes two smaller angles. Next we have that ABC is congruent to ADC. That's this one up here and this one down here. This picture looks a lot like another proof we've done recently. I think it might be one in your review. But keep in mind this is different given information. So don't treat it like it's the same problem. Make sure you know what's been given. Because on the other one we just talked about recently like this, these were given. That's not the case here. Okay, then we have AC is congruent to itself. Well, that's a shared side, so anything's congruent to itself by the reflexive property. And now what I have is I have 1, 2 pairs of angles, and I have a side that is not the side between them. 1, 2 angles, and there's the side between them, so a side that is not the side between them. So this is AAS. And notice that what we're asked to prove here is not about triangles, it's about their parts. So that's a pair of parts, a pair of sides. So I can say, now that I know the triangles are congruent, the corresponding parts of congruent triangles are also congruent. So that's a CP-CTC proof. I hope this has helped. I'm going to go ahead and finish off this video and see you later, I guess. Bye-bye.